Okay, welcome back everybody. How are you all doing today? Hopefully well. We, like I said today, we're finishing up the quiz from chapter 4.1, which was problem 2D, which we did not quite get to last time because we weren't ready for it, and then problems 4 and 5. And then we are going to finish chapter 4.3, which is a probability with and also at least one. To do today, you have Connect Math Chapter 4.1, 4.2, and Excel Lab 2 is also due today. Thursday, you have Connect Math 4.3 due, homework due, and also Excel Lab 2 is due today. However, if you have problems with it and things don't go quite right, you can turn it in late for full credit on Thursday. It will be late. It's due today, so try to get it done today. But you can turn it in late for full credit on Thursday. And then also next Tuesday you have your last homework of this section, which is Connect Math 4.4 due. Moving exam 1 to September 17th. You're going to want to go to the exam 1 study guides and review and check those out. So let me show you where those are. So this is if you go to our home page and hit start here, you'll see all of our general course information stuff at the first one. So like, how to get to Connect Math, our lectures, how to get to our lectures, our Jamboards, stuff like that, my office hours. And then our class notes and handouts, which I think most of you guys have. And then some how-to stuff. The Excel labs are all in here, right? So all the labs, descriptions, and the videos. Watch the videos. They make a big difference. I went through some work to create these videos and get them closed captioned, but they totally make your life easier. You should be able to completely do all of these with that. And then calendar of what we should be doing, and then syllabus. Down here is all the stuff for this module, this exam, chapters 1, 2, and 4. So the PowerPoints we've been doing, the board work PDFs afterwards, so you can see all the stuff that we've done, and you can see it written up. And then the link to the videos. So these are all the videos. Links to the videos, either the Zoom one or the regular one that I'm doing in this class. So you should be able to watch those there. And then the very bottom is this exam 1 study guides and review. That's really important. The #1 best way to prepare for this exam is to download this study guide and do it, right? If you download it, it looks like, I think this is it. It looks like this. Go through it. It's 8 pages long. Try to solve all the problems. Any problems you can't solve, you kind of circle them, set them aside, do all the ones you can, and then if you go back to this page here, there's the solutions. Pages 1 through 10 solutions are here, page 11 solutions are there. And then you can see, but try them first. Don't go straight to the solutions. Try them first so you know what you know and you know what you don't know. And then take a look at the solutions to make sure you know what you know and to find out what you don't know. There's also these practice exams, which I'll do in review sessions, but so you can download that also if you want to, but that is less important than the study guide. The study guide is the #1 best way to prepare for this exam, 100%. Okay, so we are here. Here's some information about the exam. It will be in Proctorio next Thursday. Proctorio is where you scan your environment, and then it takes a picture of you, it takes a video of you while you're taking the exam. Usually it's focused upon your face and watching your eye movements and that sort of thing. Instead, I'm going to have you tilt it down so it's focused upon your hands and the working area, which means that you probably want to, ideally you want to have something where a camera that you can tilt down a little bit. Or maybe if you have a computer and it's on the computer, maybe you tilt it back up a little bit so it tilts down a little bit, so the camera angles down a little bit, so you can, you can have a little bit of room to work there. And then you probably want to, I'll go through this next class, but you probably want to like stack a few books maybe to have a higher surface working area, and because you do need to, I need to have the camera on your hands and what you're doing, what you're writing, what you're using, the tables you're using, the calculator you're using, the phone that you're not using, things like that, right? I need to be able to see what you're doing. It covers chapter. Why am I reading this? Let's get Adriana. Go ahead and read for us.
In Canvas Pictorial, Thursday, September 17th, camera focused on hands and working area. Covers chapter 1, 2, and 4. See study guide for topics covered. Bring pencil, half-page, one-sided of notes. Must be handwritten. 8 pages of blank paper to show work. Basic calculators. Still have to write formulas for 4.4. Upload handwritten work after exam and assignments and extra credit for support course.
Great. So, some of those key things is you get a half-page, one-sided of handwritten notes by you. So you need to show me in the camera your handwritten notes, and you can use those. You also have to show all the problems on blank paper, show your work. So you need to bring some blank sheets of paper, and you need to do the problems on there because you're going to be uploading those, taking pictures of those and uploading those afterwards. I need to see your work as well, because it's not just the answer, it's also how you got there. And yeah, those are the kind of the key things there. All right. Some people are having trouble getting the Excel, the analysis tool pack to load in or to find it. So these are instructions for Windows. Take a picture of that if you need to. It'll be there. I'll leave it up for 5 more seconds. 5, 4, 3, 2, 1. If you have a Mac, then you want to take a picture of this one. It's slightly different. In the Mac, you'll use the Tools menu with the Excel add-ons. So if you have a Mac, you should take a picture of this one instead. It will make your life much easier. Otherwise, you won't be able to do it. And again, these work with Office 365. So I'll move on. Take a picture now because I'm moving on in 5 seconds. 4, 3, 2, 1. Okay. This is a review from last class, additional rules for probability. So how about Kristen, go ahead and read for us. Kristen R.
Rules for probability. 2 events are mutually exclusive events or disjoint events if it is impossible for them to occur simultaneously. Exclusive means separate. Addition rules. Probability of A or B equals probability of A plus probability of B, mutually exclusive. Probability of A or B equals probability of A plus probability of B minus probability of A and B, not mutually exclusive.
Perfect. That's great. Thank you so much. Excellent. And nice job reading those symbols too. Perfect. So this is kind of what we went over this last time, right? Mutually exclusive means that they cannot occur simultaneously. You cannot be both at the same time. That's mutually exclusive. So this is your quiz problem 2. Let's see what people said about it. Let's see if anybody did it. Right, so for example, here's somebody, they said, are yellow and male mutually exclusive? And the answer is no, because you can be, in other words, here are the yellow labs, here are the female labs, and there are some that are both yellow and female. So because you can be both simultaneously, you can be a yellow lab and a female lab at the same time, then it is not mutually exclusive. Good. Quiz problem number 4. Let's see, this one looks good. Great. So, so what you should ask yourself, first thing is, what are the 2 things that I know about any pizza? So I randomly pick a pizza. What are the 2 things I know about them? Whether they're cheese or 1 or more toppings. What's the other thing I know about them? Where they're eaten. Eaten at work or not eaten at work. So the type of pizza and where they're eaten. Those are the 2 things I know. So you're going to use those to set up your options here and your options there. Right? Either work or not work, cheese or more. And then you're going to fill these things in. So you're going to say, okay, I know they give me the 25. They gave you this, they gave you that. They also gave you this and that. If you know these 2 things, you can subtract them to figure out this guy here, right? Because if Out of 25 cheese pizzas, 14 are at work. That means the rest were not at work. So 25 minus 14 equals 11. And that's the number that goes there. Likewise, you can find the same thing here, right? This is 19 minus 11. That's where you get your 8 from. And once you have that, you can fill in the rest of them. You just add up to get this and this and that. And then, probability that a cheese pizza not eaten at work. Let's see, cheese pizza not at work, that's this, 11 out of 44. Good. And you can leave it just like that. I'm happy with that. If you really wanted to, you could write it as 1/4. I'm fine with that as well. You could write 25%. I'm fine with that as well. You can write 0.25. I'm happy with any one of those. So you can also write 1/4, 25%, 0.25, or just like this is totally fine as well. I'm good with all of those. I don't care. My math lab may care. It may ask you specifically for something, and if it asks you for something specific, you need to give it exactly what it asks for. But I am a lot less picky. Okay. Next one is quiz problem number 5. So this is also from your homework, right? So these two problems, I have them in here because these are going to be in your homework. And I want you to be able to see them before you get them somewhere else. So here's the Venn diagram way of doing it. Somewhere. There we go. Someone from group 1, do you want to explain this?
So basically, you have the total on top of them having mushrooms or pepperoni in the pizza, 0.63. So, and it mentions the pepperoni is 0.16, and the mushrooms are 0.38.
Right, mushroom. So, you guys know this is mushroom only, so it doesn't count the mushroom and pepperoni. You can either have pepperoni only, mushroom only, or one that has pepperonis and mushrooms in it. Keep going.
And since you know that it's 0.63 in total, you can add the amount that you know for mushrooms and pepperoni only together, you get 0.54.
Yep.
You subtract from the total, and you get 0.09.
Exactly. Beautiful. So yeah, you kind of think of this as being like X, right? So you know that this plus X plus that equals 0.63. So you found out this part here and you subtract it to get your X. Perfect. You can also do it the way they did it in the homework. This is how they did it in the homework, I think. Right, so first you have to note that probability of A is really the probability of A only plus probability of A and B. So here's A. It's this whole big light green stuff, which is the mushrooms only plus the mushrooms and pepperoni. So it's A only plus A and B. And B is really B only plus A and B. So the light blue stuff is the B only. The yellow stuff is the A and B. So those two together make up the B. And then you can substitute those into your into this guy, right? Probability of A. We replace that with A only plus A and B. And B replaced with B only plus A and B. And then we subtract off the A and B, and you'll notice that these two are the same. I'm adding one, I'm subtracting it, they cancel out, and you're left with this part here. This, I think, is more complicated. I think the Venn diagram is just such a cleaner way of doing it. It's just, it makes more sense. But if you really like formulas and things like that, then you might be good with the other one. It's a little more conceptual and algebraic, but that works fine. Okay, we did this already. You guys also did this already. You guys are in great shape. So we're going to hop right into multiplication rules and conditional probability. This is the last thing we did last class. So if you are watching from another class, you're going to want to watch the last 15 minutes of the previous lecture from the 5 o'clock class in order to catch the last 8 slides we just did, that this class did last time. Okay, so let's get someone to read this part here. How about Sky? Go ahead.
Whole slide, right?
Yeah, do you go by Sky, don't you?
Yeah.
Okay, great.
The multiplication rules and conditional probability. Multiplication rules are probability of A and B equals probability of A times probability of B, which is independent. The probability of A and B is equal to the probability of A times the probability of B over A.
No, B, almost. B given A.
Given A.
If it's
Totally
different.
forgot that one.
No worries, all good.
The conditional probability of B given A
Nice.
means probability of B given A. Given A has happened under the condition that A has happened.
Great. Good job. So, and means multiply. People always want to try to add it. And means multiply. Everybody say it with me. And means multiply. Even if you're muted at home, that's fine. Just say it with me anyways. 1, 2, 3. And means multiply. You need to know that. It's going to come up over and over and over again. Not just this chapter. It's going to come up again in chapter 5, chapter 6. I think it even comes up again in like chapter 10 somewhere. It comes up. So it's really an important idea. And means multiply. Or means add. So here are the ors, right? Ors you add. So A or B, you add. It becomes bigger. A or B, ors you add. Someone say that. Ors you add. Ready? 1, 2, 3. Ors you add. And you multiply. Super. Exactly. Thank you. Super important that you guys know that. It's gonna, like I said, it's gonna come up again and again, not just this chapter, but other ones. We talked a little bit about this one. Right, me flipping a coin and rolling a die. Right, I'll do it again just quickly. Right, so here is my dice, die, singular of dice. What's probably I roll a 4, guys?
1 out of 6.
1 out of 6, excellent. Now, I'm going to take a card, and I'm going to flip it. Oh, there you go. Oh, all right, so this is heads, this is tails. I'm going to flip it, and it came up tails. Well, say it came up heads, that's fine. Now that it came up heads, I flipped the coin, it came up heads. Now what's the probability that I roll a 4?
1 in 6.
Still 1 in 6, it doesn't change. So rolling a die and flipping a coin, are they independent or dependent? In other words, is the probability of rolling a 4 the same as the probability of rolling a 4 given I flipped the tails on my card?
They're independent?
They're independent. They're the same. These probabilities are the same. So since the probability doesn't change, they are the same. What you're comparing is, I'll write it up here, probability of rolling a 4 equals 1 in 6. Right? It's the same thing as probability of rolling a 4 given I had a tails or heads, doesn't matter. They're both 1/6. Since they're the same, so they're independent. I'm going to make this smaller so it fits. Does that make sense for folks a little bit? If knowing that if this happening, if given this doesn't change the probability, if they're the same still, then they're independent.
What
In other
are you
words,
looking at?
oh, I'm so sorry. Thank you so much.
Don't worry.
Thank you guys. You guys are very, very kind. All right. So since the probability of rolling a 4 is the same as the probability of rolling a 4 given I flip the tails on my card, they're both 1/6, they're the same, it remains the same, then they're independent. Does that make more sense?
That's very young. I'm a little confused.
Uh-huh. That's okay.
So, you said that they were the same, but like, I don't understand how they're the same. A coin is like 2 sides of I 6 and then.
Okay, so, what's the probability that I roll a 4?
1 out of 6.
Great.
On the
Now, I take a coin and I flip it. My coin comes up tails. Now, after that, given that I just flipped the tails, now it's probably I roll a 4.
wouldn't it still be the same?
It'd still be, yeah, it wouldn't change. It'd still be 1/6. This does not mean and a tail. This means given I hit a tails. So knowing that I've rolled a tails, does that change the probability of rolling a 4?
No.
Nope, it's still the same. So they're independent. You're welcome. I don't know that we did these. Did we do these? We did these, didn't we? I want to do them again. Yeah, so let's go ahead and take a look again. I want you guys to take a look at this one. We'll go through it one more time because I think people are a little bit lost on this part. So, for example, probability of female. What's the probability of female? Well, okay, so first, female and yellow. I want to know if female and yellow are independent or dependent. These are the things I care about, female and yellow. So my question to you is, what things on this board have to do with being a female or being yellow? Or being a female yellow? So, Olivia, give me one.
The number 4.
Number 4. Which one?
The one below the yellow.
Yep, this
in the
one.
yellow column.
Yep, yellow female. Perfect, that's one.
Yeah.
Zachary, give me another one. Zachary, what's another number that has to do with being yellow or female?
That's 2.
2? This has to
No,
do
no, sorry, I was reading.
yellow or female. What's another number that has to do with being yellow or female? Okay, so I'm going to help you out there and say 8. Why? Because if I said, hey, I want to know something about females. Well, there are 8 of them. Does that make sense? Aiden, give me something else about yellow or female. That has to do with yellow or has to do with female.
6 under the yellow.
Yeah, because there's 6 yellow dogs. And then there's your total. All right, so now, Zachary, here's the deal. You take these fractions, 4 over 6 and 8 over 20, and you ask yourself this question. You say, is 4 over 6, right? 4 over 6, 8 over 20. Is 4 over 6 equal to 8 out of 20? And here's the easiest way to do that. Bust out your calculator and put them in. This will end up being 0.66667. This will end up being 0.4, I think. So are they the same?
No.
No. So they're not the same. No. So they are dependent. Is that clear for people? Somewhat? You're taking these ratios and you're seeing if they're the same. And you can do either way. You can do 4 over 6 compared to 8 over 20, or you can do 4 over 8 compared to 6 over 20. Either way, it doesn't matter. They'll either both be the same or they'll both be different. So I know we did it already, but I'm going to have you guys do this one again. Very quickly, female and chocolate. 40. And again, we want to know if the probability of female is the same as probability of female given chocolate. So what's probability of female? Everyone, anyone? What's probability of female?
15 out of 40.
Yeah, there's 15 females out of 40. Now, given chocolate, so in other words, given chocolate, given it's one of these guys, what's probability of female then?
3 out of 8.
3 out of 8. Perfect, because there's 3 females out of 8 total. So this would be 3 out of 8. If you find those in your calculator, you'll see that they're the same. The other way of doing it is, again, finding numbers that have to do with female or chocolate or female chocolate. So, Zach, I'm going to come back to you, so you can give me one now. Give me something that has to do with either chocolate or female chocolate. Give me one number.
So there's 8.
Yep, 8. Because it's 8 chocolate.
Chocolate.
Perfect. Terrific. Dylan, give me another one. Dylan, 8? 3. Perfect. Because there's 3 that are female chocolate. Great. How about Alay? Give me another one. You can chat it if you want. 15? Perfect, because there's 15 females, and then there's the total. So you're going to do, say 3 over 8 is equal to 15 over 40, and you know what? Those are the exact same ratios you did here. This just helps you find those 2 ratios to see if they're the same. That's the easy way of finding those ratios. And you'll find out that they both equal, right, this equals 0.375. This one equals 0.375. So they're the same. So they are independent. Make sense? These 2 are the same.
Professor, yeah?
Yes.
Question. So female given chocolate, is 3 out of 8 and not 3 out of 40 because...
Whoa, what is it? 3 out of 40 would be chocolate and female.
Right, okay. I don't know why. Thank you.
Right. So given means you know that they're chocolate. If I say, hey, it's a chocolate puppy, if I'm giving you the fact that it's chocolate, then you know it's chocolate. You know it's one of these 8 puppies. Does that make sense?
Yeah, okay.
So now you know it's got to be one of these 8. That's the thing about given. Given, and that's the beautiful thing. See this hint where it says, looks like female chocolate? I'm going to clear this for a second. Looks like female chocolate, divided by chocolate. The given tells you what to divide by. Whenever you're given something, it means you're not working with all 40. Now you're working with a subset, a smaller group. And what are you going to divide by? Says division. This given sign looks sort of like a division sign. You take everyone can find this one. They don't know how to find what you divide by. Divide by the total chocolates. And that kind of tells you oh yeah, I have to divide by the total chocolates. Does that make any sense? So that's kind of a good hint. One of my students pointed that out a couple years ago, and I was like, oh, that's super cool. So I point that out every time when I can. When I remember.
Thank you.
Sure, good questions. You guys are asking great questions. Okay, good. So now you guys are going to do tossing a coin, lab 13. I'm not asking if they're independent or dependent. This is different. Now I'm just finding the probability of both of them happening. And we decide they're independent, so you should just be able to use these rules, right, to find them. So I'm going to give you guys 3 minutes to draw this tree. Lab problem number 13. It is the next one in your sheet here. 3 minutes, hop in there, draw the tree, and then find the probability. And if people haven't found it in a minute and a half, haven't drawn the tree in a minute and a half, then I'm going to send somebody from another class in to help you. Elaine, what room are you supposed to be in?